Hi everybody, today we have our first video about the law of sines. The law of sines helps us solve oblique triangles. An oblique triangle means we have a triangle that does not have a 90-degree angle. This means the triangle could be acute or it could be obtuse. To solve an oblique triangle means we want to find the lengths of the sides and the measure of its angles. We need to know the length of at least one side and either two of the angles, one angle and the other side, or the other two sides. We can break that down into four cases. Case 1, one side and two angles, is known as angle-side angle or side-angle angle. The difference between angle-side angle and side-angle angle is where the angles are located. If the side is between the two angles, we call it angle-side angle. If the side is not included between the two angles, we call it side-angle angle. Case 2, we have two sides and the angle opposite one of those sides. We call that side-side angle. Case 3, we have two sides and the included angle, which is called side-angle side. And then case 4, we have all three sides of the triangle. If you prefer to see that visually, you can refer to this graphic. The law of sines says for any triangle with sides A, B, and C, and opposite angles labeled capital A, capital B, capital C, then sine A over A is equal to sine B over B, which is equal to sine C over C. We can express that as three different equations. We can write sine A over A equals sine B over B. We can have sine A over A equals sine C over C. We could also have sine B over B is equal to sine C over C. Our angles A, B, and C will always add up to 180 degrees. Cross multiplication will be really important when we solve using the law of sines. So as a reminder, A over B being equal to C over D means that A times D is equal to B times C. Now we're ready to try our first problem. We have an angle A of 48 degrees, we have an angle B of 61 degrees, and we have a side A equal to 7. We would call this a case of side angle angle. To start, I'm going to say that the sine of 48 over the opposite side 7 is equal to the sine of 61 over the unknown side b. To solve for b, I'm going to cross multiply. I have b times the sine of 48 is equal to 7 times the sine of 61. b then will be 7 times the sine of 61 over the sine of 48. Our first step is to go to our settings and switch to degrees. Now we enter 7 sine of 61 divided by the sine of 48. We get 8.238. I'm going to write that as 8.24. To find our angle C, we're going to take 180 and subtract 48 and 61. This gives us the value of C being equal to 71. Now we can solve for the side length C by taking the sine of 48 over 7 and setting it equal to the sine of 71 over C. Again, we cross multiply. I have C times the sine of 48 equals 7 times the sine of 71. I divide both sides by the sine of 48. I have 7 sine of 71 over the sine of 48. In the calculator, we put in 7 sine of 71 divided by the sine of 48. That gives us 8.906, which I'm going to round up to 8.91. Now we have all three angles and all three sides of the triangle. Our second problem says solve the triangle where A is 24 degrees, B is 36 degrees, and C is 15 degrees. We can draw a quick triangle. We'll say A is 24 degrees. We'll say B is 36 degrees. And our value of C is 15. This shows us we have a side that's between two angles, which is why we call it angle-side angle. We can find the value of C by taking 180 minus 24 minus 36, which is 120. I'm going to set up my equation as the sine of 120 over 15 is equal to, let's say I first find the value of A. We'll say the sine of 24 over A. We know we will cross multiply. I have A sine of 120 equals 15 sine of 24. When I divide by the sine of 120, I get 15 sine of 24 over the sine of 120. When I put that in my calculator, I get that A is equal to 7.04. To find the value of B, I go back to the sine of 120 over 15. This time, I set this equal to the sine of 36 over B, which is unknown. Again, cross-multiplying gives me B, sine of 120, equals 15 sine of 36. B will be equal to 15 sine of 36 over the sine of 120. When I put that in my calculator, I get a value of 10.18. When you look at your triangles, you should always compare that the smallest angle should have the smallest side. The largest angle should have the largest side. When solving side-side angle triangles where two sides and the angle opposite one is known, this is called the ambiguous case. The information can result in one triangle, two triangles, or no triangles. We're going to go over a few examples to see what that really means. We'll start with a triangle where A is 8, side C is 3, and the angle C is 55. We'll do a quick sketch. Here I have angle A with side 8. I have angle C, that's 55, has a side length of 3, and then B is unknown. We can use that the sine of 55 over 3 will be equal to the sine of A over 8. We cross multiply to get 8 sine of 55 is equal to 3 times the sine of A. To find the sine of A, I have 8 sine of 55 over 3, and this will be the sine of A. To get A, I'm going to have to use the sine inverse. So we'll write the sine inverse of 8 sine 55 over 3. In our calculator, we're going to pull up sine inverse of 8 sine 55 divided by 3, and it says undefined. Let's look at that a little closer. Let's look at the 8 sine 55 over 3. Notice that it gives us a value of 2.18. Sine only goes from -1 to 1, so getting this value of 2 means that I can't find the sine inverse, which is why it's undefined. This case tells me that I have no triangle. Let's try another one with side-side angle. This time I have A is 13.9, B is 20.3, and angle A is 30. We'll draw a quick sketch so we have some reference point, but these are never to scale. A is 30. It has a side of 13.9. B is unknown. It has a side of 20.3. C is also unknown, and we don't know the side length. Using the law of sines, we have that the sine of 30 over 13.9 is equal to the sine of B over 20.3. We cross multiply to get 20.3 sine of 30 equals 13.9 sine of B. I'll divide 20.3 times the sine of 30 by 13.9, and that will be equal to the sine of B. After we get this ratio, we'll find the sine inverse of 20.3 sine of 30 over 13.9 to get our angle B. Let's take a look at our fraction before we find the sine inverse. I have 20.3 sine of 30 divided by 13.9. We got an answer between -1 and 1, which says when we find sine inverse, it'll give us an angle. I'm going to add the sine inverse to the beginning of the fraction, so I'm going to put in sine inverse. I'm going to add parentheses, and it says our angle is 46.9 degrees. This is where we need to stop and think about inverse angles a little bit. When we think about sine, I had this ratio that gave me 46.9, but sine is positive, in both quadrants 1 and in quadrant 2. So there's a second angle that goes with this same ratio. To find our other angle, I look at this as being a 46.9 degree reference angle, and I find 180 minus 46.9. This says my second angle is 133.1 degrees. What happened here is I have two cases. So when we talked about side-side angle, we said we could have no triangle, we could have one triangle, or we could have two. This is a case that has two triangles. In case 1, we're going to let B be equal to 46.9 degrees. A will still be 30, and the side will be 13.9. B will be 46.9, and we know the side is 20.3. Now we need to find angle C and side C. To find angle C, we're going to take 180 minus 46.9 minus 30. This gives me that C is 103.1 degrees. To find the side C, we'll start with the sine of 30 over 13.9 is equal to the sine of 103.1 over C. Cross multiplying, I have C sine of 30 equals 13.9 times the sine of 103.1. We'll divide by the sine of 30. This says C is 27.08. For case 2, B will be 133.1 degrees. A is still 30. We still don't know C. A corresponds to a 13.9 side. B corresponds to a 20.3 side. We'll start by finding our angle C. C will be equal to 180 minus 30 minus 133.1. This says C is a small 16.9 degrees. Then to find our side C, we have the sine of 30 over 13.9 is equal to the sine of 16.9 over C. Cross multiplying one more time, I have C sine of 30 equals 13.9 sine of 16.9. Divide by the sine of 30, which says C is 8.08. To help you visualize our results, I made two triangles, case 1 with an acute angle, case 2 with an obtuse angle. We'll do applications of the law of sines in the next video.